And now let's move on to section 18E, rules for integration. In your textbook there are rules about derivatives and integrals from pages 457 to 458. So please go ahead and take a look at those, and you'll see then how I'm getting all these integrals that we're dealing with here. So pause the video now if you wish to take a look at those, or keep them handy for reference when we go through these examples. So, like we saw in 18D, the integral of a sum of functions, sum or a difference of functions, is the sum or difference of the integral of those functions. So we can actually break these up into 5 different functions and take the derivative, or sorry, the integral of each one of those. So again, when we take the integral of x to the power 4 in this case, we add 1 to the exponent, and then because we add 1, if we think ahead now and we take the derivative, that 5 will come down in front, but we don't have a 5 here, we got a 3. So in order to counteract this 5 being brought down in front to multiply, we want to divide by that 5. Okay, so this is the integral of 3x to the power 4. Then over here, we add 1 to the exponent here, so that gives us x cubed. And then now we take the derivative of that, the 3 would come down in front, and we want to end up with 1/2. So if we take this 1/2 and divide by 3, I'll just write it up here, so we got 1/2 divided by 3. Well, that 3 is actually 3 over 1, and so then when you divide fractions, you flip and multiply to get 1/2 times 1/3, which then gives us 1 over 6. So instead of having 1/2 divided by 3, we can just write that as negative 1 over 6. So then when you take the derivative of this, bring the 3 down in front, it's negative 3 over 6, which does reduce down to 1 over 2. And then for this last term, we want to add 1 to the exponent, so that becomes x squared. If you take the derivative of this, the 2 will come down in front, and we want to be left with 5, so we got the 5, and we have to divide by 2, because when you take the derivative you multiply by 2, and the 2 2's will cancel to leave you with 5 in front, and then we add in the constant. Okay, so this is the integral of this original function with respect to x. Now we're going to up the game a little bit here, so we want to get the integral of cosine x minus 3 e to the x dx. Please put brackets around that because I forgot those. And so now we have to think about, these are special cases of functions, and so when you think back to what we did with derivatives, we want to undo the derivative or differentiation of cosine x. So what would we differentiate to get cosine x? That would be sine x. So you take the derivative of sine x and you get cosine x. Okay, so that works. And then here, remember that e to the x, the natural log or the natural exponential e, when you take the derivative of that, we just get itself. So the derivative of e to the x is just e to the x. And if you have a coefficient in front of it, that just stays anyways. So the integral of negative 3 e to the x is just negative 3 e to the x. And then we add c for good measure. We move over to part C. Again, brackets. When we have things in the denominator, I usually like to rewrite them so it's just a little bit easier to understand what's happening. So I bring this x up beside the coefficient of 2, which gives the exponent of negative 1, and then bring this root x up, and we're going to also change the root x, the radical, into a exponential form, so we get negative 3 x to the negative 1/2 dx. Okay, so we haven't taken the integral yet. We're going to do that now. We're just rewriting it first. Okay, so when you look back at page 457, 458, you will see that the integral of 1 over x is actually the ln of x, the natural logarithm of x. And in the textbook it shows you two cases when x is positive and x is negative. As it turns out, they both end up being the same thing. So the integral of 1 over x, here we got the 2 in front, so 2 times 1 over x, that just becomes the ln, the natural logarithm of the absolute value of x, which is the modulus of x. And so anytime you want to find the integral of a reciprocal type of function, it's always going to be the natural logarithm of the absolute value of x. And then here we've got x to the negative 1/2. Well, if you add 1 to this, you get x to the positive 1/2. If you take the derivative of this, this comes down in front to multiply. You subtract 1 from the exponent to get negative 1/2, so that part's good. And we want to, just like we did over here, we want to divide 3 by 1/2. So if I put this over here, 3 divided by 1/2, this is actually 3 over 1 divided by 1 over 2. And then you flip and multiply, so you get 3 over 1 times 2 over 1, which gives 6. So that when we bring this 1/2 down in front and multiply by the exponent, or sorry, the coefficient, we're going to end up with a 3. So that is going to be 6 there. And then we add on c. I'm going to change this back into radical form because that's the form that we were given in the original question. So this will be 2 natural logarithm of the absolute value of x minus 6 root x plus c. And then we move on to part D. Anytime there's a sum in the numerator, what I like to do is split that up. So it's the integral of 4x cubed over root x plus 7x over, actually this time I'll write it as x to the 1/2. I could have written both of them like that, but I'll just ease you into it. So this is also, of course, x to the 1/2. So 4x cubed divided by x to the 1/2, we're dividing powers. So what do we do to the exponents when we divide powers? Subtract exponents, leave the base the same. So we haven't done any integration yet, we're just simplifying things. So we got 4x to the 5/2. And then we do the same thing here, and we get 7x, sorry, that's a 7, x to the 1/2 dx. Now we take the integral of each one of those parts. So we're going to have 4x. Now we're going to add 1 to this. So 1 in fraction form with a denominator of 2 is just 2 over 2. So we get 4x to the 7/2, and then just like everywhere else, we've been dividing by the new exponent. So we're going to divide by the new exponent and do the same thing here. So this is going to be 7x to the 3/2 divided by 3/2 plus c. And then I'm just going to simplify this part here. So that's 4 over 1 divided by 7 over 2. We flip and multiply, and we end up getting 8 over 7 x to the 7 over 2. And then we do the same thing here, flip and multiply, and get 14/3 x to the 3/2 plus c. Now, I could spend the time and change these back into radical form. I don't really feel like it right now, but you could do that. What would that be? X cubed root x and x root x. So I guess I did feel like doing it, but just not writing it down. So x to the 7/2 is x cubed times root x, and x to the 3/2 is x times root x. And of course the coefficients, of course, will stay the same, and the c will also just stay there. Okay, and now for the last example, We want to find f of x given, the second derivative being cosine of x. We know f prime of pi by 2 equals 0 and f of 0 equals 3. And these will be important in a second, and you'll realize why momentarily. So we have to go up in stages. We've got the second derivative here, so we have to go back twice. So the first derivative is equal to the integral of the second derivative, which is f cosine x dx. And so then you ask yourself, well, what do you take the derivative of to get cosine of x? And that would actually be sine of x. And then we add c, just for fun. Now here's where this comes into play. Because we want to do a second integral, we actually need to know what that value of c is. So what we're going to do is we're going to substitute pi by 2 into x. And we know that that equals 0. So sine of pi by 2 is 1 plus c equals 0. Therefore c equals negative 1. So therefore f prime of x is sine x minus 1. So now, that's the first derivative. We want to get back to the original function. So we're going to say f of x equals the integral of f prime of x dx, and that f prime of x is sine x minus 1. And so then of course you ask yourself, well, what do you take the derivative of to get positive sine x? Well, you take the derivative of cosine x to get negative sine x, so we would take the derivative of negative cosine x to get positive sine x. And then here's the negative 1, so that gives us negative x plus, now we've already used c, so I'm going to use d here as the new constant. So now, because we're given these specific values, we're going to have to substitute 0 into this to find what the d value is. So f of 0 is negative cosine of 0 minus 0 plus d, and that equals 3. So the cosine of 0 is 1, and multiplied by the negative, so it's going to be negative 1 minus 0, well that's just minus 0, plus d equals 3. Add 1 to both sides, so you get d equals 4. Therefore, the grand finale, f of x equals negative cosine of x minus x plus 4. So, here's a little bit of work for you for the weekend, if it happens to be the weekend when you watch this video, and just enjoy that, and thanks for watching, and we'll see you in class.